In this video we're going to talk about torque, and torque is an extremely important topic, and unfortunately we're not going to give it nearly as much time as it deserves. Okay, so we've got torque, and we can think about that as a torque is basically a force that causes rotations. And so we have this equation where that is a Greek letter tau, and this is force, and this is distance from the axis of rotation. Okay, and so then there's ways that torque relates into centripetal acceleration, which I really should be getting into, but I'm not going to be getting into. But rotating forces cause rotating accelerations. So when we are talking about centripetal acceleration, we would have to introduce the concept of angular acceleration, and torques would cause angular accelerations, and I apologize right now for not having enough time in the year to go into that as deeply as I would like. Okay, so let's consider that we have a simple situation here. We've got a rock, and the rock weighs, let's say the rock weighs 1,000 newtons. Okay, so now we weigh, or let's see, let's make it 2,000 newtons. 2,000 newtons. Now we weigh about 700 newtons. So out here we can apply 700 newtons of force down on this lever, and we want to lift the 200 Newton rock up in the air. 2,000 Newton rock up in the air. Well, what is the ratio? Well, suppose this whole thing is I think it's reasonable for a rock bar to be about 5 feet long, so let's call it 1.75 meters. So we're going to call this x, and we're going to call this 1.75 meters minus x. Well, what I know is I want that force 1 times radius 1, I want that to be equal to force 2 times radius 2. So that if I have equal torques on either side, or if I have slightly more torque on this side, then I'm going to be able to lift the rock. Okay, so I've got 700 newtons times 1.75 meters minus x is equal to 2,000 newtons times x. So, doing a bunch of mental math here, I'm going to get, I won't do mental math, I'll do it out of my calculator. 700 times 1.75, that's 1,225 Newton meters minus 700 newtons x equals 2,000 newtons x. So I have 1225 Newton meters equals 2700 Newton x. So X is going to be 1225 Newton meters divided by 2700 meters. So X is going to be 45 centimeters. So what I want to do is I want to set it so that this is 130 meters, or 1.3 meters, or 130 centimeters, and I want this to be 0.5 meters. And so in that situation, then if I put my entire weight onto that bar, then I will counteract the force, the torque that the rock is applying to the other end of the bar, and so the bar will go up. Okay, I think I'm going to leave that there, and then I think I'm just going to come back and do one just sort of lever problem in equilibrium and call it good.